In this lesson, we want to talk about the sets of numbers that make up the real number system. Our real number system is going to be the set of numbers that we use throughout this course, so we want to look at exactly what makes up this set of numbers. The first group of numbers we want to talk about is the set of numbers that is commonly called the counting numbers. But more formally, they're typically called the natural numbers. Now, since they are sometimes called counting numbers, that makes it easy to guess what exactly they consist of. Of course, when we count, we start at 1 and we count 1, 2, 3, 4, 5, and then, of course, on from there. So even though the counting numbers, or our natural numbers, is the smallest collection of numbers that we will work with, they still have an infinite number of values within them. Now, the way this structure works is we take the set of numbers that we just discussed and we add to it to build yet another larger set. Now, what's missing from the counting numbers that we're going to add to it is a 0. When we add the 0, we form a whole new collection of numbers that we call the whole numbers. With this 0, we are able to do things like place value, which would be impossible without it. All right, we again are going to build a larger collection of numbers by taking what we've got and adding to it. And if you think about what's missing at this point, you notice there are no negatives. So if we were to add -1, -2, -3, -4, and so on, then we would form a set of numbers that's commonly called the integers. Now, as you can see, there's still a lot of numbers missing, numbers that haven't fallen into even any one of these sets of numbers. So we go on building. We go on taking everything we've mentioned so far and adding to it. Now, what is missing at this point is anything that is a true fraction. Fractions like 1/2, 3 5/8, that's a mixed number. We also haven't seen any decimals, numbers like 1.5 and so on. The set of numbers that would take in the counting numbers and the whole numbers and the integers and your fractions is a set called the rational numbers. For a number to be a rational number, that just means that that number can be written in a fractional form. Now, since we can't list fractions in order, every time you list a couple of fractions, you miss something, we simply say that our rational numbers, we will symbolically write them in the a over b form, where, of course, a and b have to be integers, and we definitely do not want to let b be a 0, because that would make the fraction undefined. Now, other decimals that we haven't mentioned yet that are going to still fall in the rational numbers are the decimals that are infinitely repeating, like 0.33333 repeating, or 0.125 repeating. And we can go to the calculator and see that those numbers are in fact rational numbers. Because if you, for example, take 1/3 and put that into a decimal form, that's where the repeating 3 comes from. So again, any decimal that goes on forever, like this one does, but has a repeating pattern to it, is going to fall into the rational number category. Now, at this point, when we look at our next set of numbers, we break away from this building process. The next set of numbers does not take in any of the previous. The next set of numbers, as a matter of fact, stands separate from the rational. Now, since rational means this is a number that can be written as a fraction, then the next set of numbers which are called the irrational, is going to consist of the numbers that cannot be written in a fractional form. And there are several examples that we can come up with. For example, from geometry, you learned about pi. Pi is an irrational number. When you pull pi up on your calculator, you get a decimal that goes on forever and has no pattern to it whatsoever. So pi is a good example of an irrational number. Another common way to come up with irrational numbers is to take the square root of anything that's not a perfect square. For example, the square root of 2 is an irrational number. When you pull it up on the calculator, you will find that you get a decimal that again goes on forever but has no pattern to it of any kind. So irrational numbers are easy to list. We would have, say, square root of 2. We could say square root of 3. But we wouldn't want to say square root of 4 because we know square root of 4 to be 2, and 2 is already listed up here in our natural numbers. So the next one we could list would be perhaps square root of 5, and we can go on from there, avoiding our perfect squares. So we now see that we have two large sets here, rational and irrational, that are disjoint from one another. To come up with our final set of numbers, we will bring these two together, and this final set of numbers is just a combination of the rational and the irrational, and it's the real number system, which is what we're going to be working with in our algebra class. Now, each one of these sets have a symbol to go with them. Your real numbers, for example, is typically symbolized by a bold R. Our natural numbers is symbolized by an uppercase N. Our whole numbers is symbolized by a W. Our integers by an I. So far the symbols are pretty obvious as far as what should be used. For our rational numbers, though, we can't use the R because the R has been already used with the real numbers. So the symbol that's used with the rational numbers is the uppercase Q. And also with the irrationals, we can't use an I because that's already in use for the integers. So for the irrational numbers, we're going to use an uppercase H to represent them. So these are the sets of numbers that we will be working with in our algebra class and the symbols that represent them.